All right, in this chapter, or section in 6.4, we're now going to take all the different types of factoring problems that we've learned over the last three sections, 6.1 through 6.3, and kind of just all combine them together. And what I've tried to do here is combine or create a flow chart that may help you do this. So this is how the flow chart works, and I'm going to keep referring back to this as we do problems together in this section here. All right, so when you start with factoring, you always do factor the GCF. So regardless of whatever the problem looks like, we are always going to factor out the GCF first. If it has one, cool, but that's the first thing you do. Okay. So from there, you ask yourself now, does our problem have 2 terms, 3 terms, or more than 3 terms, like 4 terms, all right? And so this is how you know where to go then. So if it has 2 terms, then you're going to use either difference of squares, difference of cubes, or sum of cubes. If it has 3 terms, then you're either going to use perfect square trinomial, or you're going to use what we learned in 6.2, which is when you factor a quadratic when a is bigger than 1, or when a is bigger, or when a is equal to 1. And then if it has more than the 4 terms, then you're going to use the factor by grouping. So really, it just matters on how many terms you have and what order that it fits. So let's take a look at our first problem right here. All right, we have 21x cubed y squared minus 27x squared y to the power 4. So let's take this problem and let's look at our chart here. Okay, so here's the problem right here. And so the first thing that we always want to do is factor the greatest common factor. So that's the first thing that I'm going to do right here. All right, so let's look at 21 and 27. So it looks like they each have, let's see, 3, maybe like, yeah, 3, right? So we're going to take out actually 3. Yeah, so let's take out a 3. Now what about x cubed and x squared? Well, they each have an x squared in common, and y squared and y to the power 4, so y squared. So now if I put what goes back inside the parentheses, so this times what gives me back this. We'll see 3 times 7 x, right? So x squared times x gives me back x cubed, and then y squared times this whole thing will just give me back y squared. And then 3 times what is 27? So that's minus 9 x squared, and then I need a y squared right here. Okay, so what I've done so far is I've just done the first part, which says factor the GCF. Okay, now we just look at what's inside of here now, because we factored that out, and this is a binomial, right? Which means we have 2 terms. So the question is this now. By looking at this right here, is that a difference of squares? Can I write the first term as something squared and the second term as something squared? Well, the second term you can write. You can write this as a b squared, like this would be 3y and then squared. But you can't write 7x as a square, so it's not that, all right? It's not a difference of cubes. There's no cubes anywhere here, and you can't write 9 as a cube or that. So basically, because we checked all those off, then that means that we're done now. These are the only 3 possibilities of factoring a binomial, so we're done with that problem. Okay, so that was So that was the first one that we just did here. Now let's go ahead and do the second one. Again, we have two terms. It just looks bigger, but this is our first term, and that's our second term. Notice that they have a common factor of n minus n, so I'm going to factor that out. M minus n. So what goes back inside? Well, it would be 8y goes back inside, and then minus 5. And if I look at this, it's not a difference of squares, it's not a cube, so we would be done then.